Humidity and UV radiation can both cause damage to various materials, from wood to plastics to fabrics. Moisture can lead to mold and mildew growth, while UV radiation can cause fading, cracking, and other forms of degradation. To combat these issues, the use of chemical technologies has become increasingly prevalent in the production of moisture-resistant and UV-resistant materials. In this article, we will explore the applications of chemistry in the production of moisture-resistant and UV-resistant materials, including the types of chemicals used, the manufacturing processes involved, and the benefits of these materials. Moisture-resistant materials. Humidity and moisture can cause significant damage to materials, from warping and cracking to mold and mildew growth. To combat these issues, moisture-resistant materials are used in various industries, including construction, packaging, and textiles. The following are some of the chemical technologies used in the production of moisture-resistant materials. Moisture barriers. Moisture barriers are coatings or films that are applied to materials to prevent moisture from penetrating. These barriers can be made of various materials, such as polyethylene or polypropylene, and can be applied using techniques such as extrusion coating or laminating. Desiccants. Desiccants are chemicals that absorb moisture from the surrounding environment. Desiccants can be added to packaging materials or incorporated into products such as building materials to prevent moisture damage. Waterproofing agents. Waterproofing agents are chemicals that are added to materials to make them waterproof. These agents can be applied using techniques such as spray or dip coating. Antimicrobial agents. Antimicrobial agents are chemicals that prevent the growth of mold and mildew. These agents can be added to materials such as textiles or building materials to prevent moisture-related damage. UV-resistant materials. UV radiation can cause significant damage to materials, from fading and discoloration to cracking and degradation. To combat these issues, UV-resistant materials are used in various industries, including construction, automotive, and textiles. The following are some of the chemical technologies used in the production of UV-resistant materials. UV absorbers. UV absorbers are chemicals that absorb UV radiation, preventing it from reaching the underlying material. These absorbers can be incorporated into materials such as plastics, coatings, and fabrics. Hindered amine light stabilizers, HALS. HALS are chemicals that prevent the degradation of materials caused by UV radiation. These stabilizers can be added to materials such as plastics and coatings to improve their resistance to UV radiation. Nanoparticles. Nanoparticles can be added to materials to provide UV protection. For example, titanium dioxide nanoparticles can be added to coatings to improve their UV resistance. Light filters. Light filters can be incorporated into materials to filter out specific wavelengths of light, including UV radiation. These filters can be added to materials such as plastics, coatings, and fabrics. The production of moisture-resistant and UV-resistant materials typically involves a combination of chemical technologies and manufacturing processes. For example, coatings and films can be applied to materials using techniques such as extrusion coating or laminating, while additives, such as desiccants and UV absorbers, can be incorporated into materials during the manufacturing process. The benefits of moisture-resistant and UV-resistant materials are numerous. Moisture-resistant materials can prevent damage from moisture and humidity, improving the durability and longevity of products. UV-resistant materials can prevent damage from UV radiation, maintaining the appearance and performance of products over time. These materials are used in various industries, including construction, automotive, packaging, and textiles, and are essential for maintaining the integrity and functionality of products. In conclusion, the applications of chemistry in the production of moisture-resistant and UV-resistant materials are diverse and complex. From moisture barriers to UV absorbers, the types of chemicals used in the production of these materials are vast. Moisture barriers are coatings or films that are applied to materials to prevent moisture from penetrating. Moisture can cause damage to various materials, including wood, paper, and textiles, leading to warping, cracking, and mold growth. Moisture barriers are commonly used in various industries, including construction, packaging, and textiles. Moisture barriers can be made of various materials, including polymers such as polyethylene and polypropylene. These materials are often used in the production of films and coatings that are applied to various surfaces to prevent moisture from penetrating. The thickness of the film or coating can vary depending on the application and the level of protection required. Moisture barriers can be applied to materials using various techniques, including extrusion coating and laminating. In extrusion coating, a molten polymer is applied to a substrate, such as paper or fabric, to create a moisture barrier. In laminating, two or more layers of material are bonded together using heat and pressure, with a moisture barrier layer in between. Moisture barriers can provide various benefits, including protection against moisture damage. Moisture barriers can prevent moisture from penetrating materials, preventing damage such as warping, cracking, and mold growth. Improved product durability. Moisture barriers can improve the durability of products by preventing damage caused by moisture. Improved product shelf life. Moisture barriers can improve the shelf life of products by preventing damage caused by moisture, extending the life of the product. Enhanced product performance. Moisture barriers can enhance the performance of products by preventing moisture-related issues, such as mold growth, that can affect the appearance and functionality of products. Waterproofing agents are chemicals that are added to materials to make them waterproof. These agents can be applied to a wide range of materials, including fabrics, wood, concrete, and metal, to prevent the penetration of water and moisture. The types of waterproofing agents used in the production of materials vary depending on the application and the specific material being treated. Some common types of waterproofing agents include silicone. Silicone is a common waterproofing agent used to protect a variety of materials, including concrete, wood, and fabric. Silicone forms a protective layer over the surface of the material, preventing the penetration of water and moisture. Acrylic. Acrylic is another common waterproofing agent used to protect materials, such as wood and concrete. Acrylic coatings can be formulated to provide a variety of levels of protection, from mild water resistance to complete waterproofing. Epoxy. Epoxy is a type of polymer that can be used as a waterproofing agent for various materials, including metal, concrete, and wood. Ceramics are a class of materials that are widely used in various industries, including construction, aerospace, and electronics. Ceramic materials are typically made from inorganic compounds such as clay, feldspar, and silica, and can be produced using various chemical methods. In this article, we will explore the production and processing of ceramic materials from chemical compounds. Ceramic production methods. There are several methods for producing ceramic materials from chemical compounds, including powder synthesis. In this method, ceramic powders are synthesized from chemical precursors through a chemical reaction or a series of reactions. The resulting powder is then sintered to produce the final ceramic material. Sol gel method. This method involves the production of ceramic materials from a sol, which is a liquid precursor containing metal alkoxides. The sol is then treated to produce a gel, which is then dried and sintered to produce the final ceramic material. Electroceramics. This method involves the production of ceramic materials from electrically conductive metal oxides. The metal oxides are mixed with a nonconductive material, such as a ceramic oxide, to produce a material that exhibits both electrical conductivity and ceramic properties. Bioceramics. Bioceramics are a type of ceramic material that is used in biomedical applications, such as bone implants. Bioceramics are produced using chemical methods, such as sol gel or powder synthesis, and can be designed to exhibit specific properties, such as bioactivity and biocompatibility. Ceramic processing methods. Once ceramic materials have been produced, they must be processed to produce the final product. The following are some of the processing methods used in the production of ceramic materials. Shaping. Ceramic materials can be shaped into various forms, including tiles, plates, and tubes, using techniques such as extrusion, injection molding, and casting. Sintering. Sintering is a process in which ceramic materials are heated to a high temperature, causing the particles to fuse together and form a solid material. Glazing. Glazing is the process of applying a thin layer of glass to the surface of a ceramic material. Glazing can improve the appearance of the ceramic material, as well as its resistance to moisture and chemicals. Surface treatment. Ceramic materials can be treated with various chemicals to improve their properties, such as strength, toughness, and wear resistance. Benefits of ceramic materials. Ceramic materials offer several benefits over other types of materials, including high strength and hardness. Ceramic materials are known for their high strength and hardness, making them ideal for applications that require durability and resistance to wear. High resistance to heat and chemicals. Ceramic materials can withstand high temperatures and exposure to chemicals without degrading, making them ideal for use in harsh environments. Biocompatibility. Certain types of ceramic materials, such as bioceramics, are biocompatible, meaning they can be used in biomedical applications without causing an immune response. Electrical properties. Certain types of ceramic materials, such as electroceramics, exhibit electrical conductivity, making them useful for applications in electronics and telecommunications. In conclusion, ceramic materials are widely used in various industries due to their unique properties and versatility. Ceramic materials can be produced using various chemical methods, including powder synthesis and sol gel, and can be processed using techniques such as sintering and glazing. The benefits of ceramic materials, including their high strength, resistance to heat and chemicals, and electrical properties make them an essential component of many products and applications. As the demand for ceramic materials continues to grow, the development of new and innovative production and processing methods will play a crucial role in meeting this demand. Bioceramics are a type of ceramic material that is used in biomedical applications, such as bone implants and dental prosthetics. Bioceramics are designed to exhibit specific properties that make them compatible with living tissue, such as bioactivity and biocompatibility. Bioceramics can be produced using various methods, including powder synthesis, sol gel, and electrospinning. The selection of the method depends on the specific properties required for the application. One of the most important properties of bioceramics is their bioactivity. Bioactive materials have the ability to bond with living tissue, promoting the growth of new bone tissue and allowing the implant to integrate with the surrounding tissue. Bioceramics can exhibit bioactivity through the release of ions, such as calcium and phosphate, which are essential for bone growth. Biocompatibility is another important property of bioceramics. Biocompatibility refers to the ability of the material to interact with living tissue without causing an immune response or adverse reactions. Bioceramics are designed to be biocompatible, allowing them to be used in biomedical applications without causing harm to the patient. Another important property of bioceramics is their mechanical properties. Bioceramics must have sufficient strength and toughness to withstand the stresses and strains of the body. The mechanical properties of bioceramics can be improved through the addition of reinforcing materials, such as carbon fibers or titanium. There are several types of bioceramics, including calcium phosphate ceramics. Calcium phosphate ceramics, such as hydroxyapatite, are commonly used in bone implants due to their bioactivity and biocompatibility. Bioactive glass ceramics. Bioactive glass ceramics are designed to exhibit both bioactivity and mechanical strength, making them useful in a range of biomedical applications. Zirconia ceramics. Zirconia ceramics are known for their high strength and toughness, making them ideal for use in dental implants. Bioceramics offer several benefits over other types of materials, including their ability to promote bone growth, their biocompatibility, and their mechanical properties. Bioceramics have revolutionized the field of biomedical engineering, allowing for the development of new and innovative solutions for a range of medical conditions. Sintering is a process used in the production of ceramic materials, which involves heating the material to a high temperature below its melting point to cause the particles to fuse together and form a solid material. The process is typically used to produce dense, high-strength ceramic materials with uniform properties. The sintering process involves several stages, including compaction. The ceramic material is first compacted into a desired shape, such as a disc or a rod, using techniques such as pressing or extrusion. The compacted material is known as a green body. Densification. The green body is then heated in a furnace to a temperature below its melting point, causing the particles to fuse together and form a solid material. The process is known as densification, and it typically involves several stages, including the removal of air and other gases from the material, the rearrangement of particles, and the formation of new chemical bonds between the particles. Grain growth. As the temperature of the material increases, the particles will begin to grow in size, a process known as grain growth. Chemical additives and compounds are widely used in the manufacturing of products to improve their properties and enhance their appeal to consumers. One such area where chemistry plays a crucial role is in the production of colorants and fragrances. Colorants are substances used to add color to a product, such as food, cosmetics, textiles, and paints. Fragrances, on the other hand, are substances used to add scent or aroma to a product, such as perfumes, soaps, and candles. The use of chemical additives and compounds in the production of colorants and fragrances has revolutionized the industry, allowing for the development of new and innovative products that are both appealing to consumers and safe for use. One of the most widely used chemical additives in the production of colorants is pigments. Pigments are finely ground particles of solid color that are insoluble in the medium in which they are dispersed. Pigments can be organic or inorganic, and their properties can be modified to achieve specific colors and effects. Inorganic pigments, such as iron oxides and titanium dioxide, are commonly used in the production of paints, while organic pigments, such as phthalocyanine and quinacridone, are used in the production of plastics and textiles. Another important area of chemical additives is in the production of fragrances. Fragrances are complex mixtures of natural and synthetic compounds that are used to add scent or aroma to a product. Fragrances can be classified into different categories, such as floral, fruity, woody, and spicy, depending on their composition. The use of synthetic fragrances has allowed for the production of consistent and safe fragrances that are free from impurities and allergens. Chemical additives can also be used to enhance the properties of colorants and fragrances. For example, surfactants, which are compounds that reduce the surface tension of a liquid, can be added to colorants to improve their dispersion and stability. Similarly, emulsifiers, which are compounds that help mix two immiscible liquids, can be added to fragrances to improve their solubility and stability. The production of colorants and fragrances also involves various chemical processes, such as polymerization, esterification, and oxidation. Polymerization is a process used to create polymers, which are long chains of molecules that have a wide range of properties. Polymerization is commonly used in the production of synthetic fragrances, as it allows for the creation of complex mixtures of compounds with specific properties. Esterification is a chemical reaction used to create esters, which are compounds that have a fruity or floral scent. Esterification is commonly used in the production of fragrances, as it allows for the creation of specific scents that are not found in nature. Oxidation is a chemical reaction used to create aldehydes and ketones, which are compounds that have a sharp and pungent scent. Oxidation is commonly used in the production of fragrances, as it allows for the creation of specific scents that are not found in nature. Colorants are substances that are used to add color to a product. They are widely used in a range of industries, including food, cosmetics, textiles, and paints. Colorants can be organic or inorganic, and their properties can be modified to achieve specific colors and effects. Inorganic pigments, such as iron oxides and titanium dioxide, are commonly used in the production of paints, coatings, and plastics. Inorganic pigments are highly stable and do not fade or deteriorate easily, making them ideal for use in products that are exposed to sunlight or harsh environments. Organic pigments, such as phthalocyanine and quinacridone, are used in the production of plastics, textiles, and other products. Organic pigments have excellent color strength and are often used to achieve bright and vivid colors. However, they can be less stable than inorganic pigments and may fade or change color over time. Dyes are another type of colorant that are widely used in the production of textiles and other products. Dyes are soluble in the medium in which they are applied, such as water or alcohol, and can penetrate the material to create a more uniform color. Dyes can be natural or synthetic and can be modified to achieve specific colors and effects. In addition to pigments and dyes, colorants can also be created using other chemical processes, such as photodegradation and chromogenic reactions. Photodegradation is a process where the color of a material changes upon exposure to light. Chromogenic reactions involve chemical reactions that change the color of a material upon exposure to certain conditions, such as heat or moisture. The use of colorants has enabled manufacturers to create products that are visually appealing and attractive to consumers. Colorants can be used to differentiate products from competitors, create brand recognition, and enhance the overall appeal of a product. However, the use of colorants can also raise concerns regarding their safety and environmental impact. As a result, regulations and standards have been put in place to ensure the safe use and disposal of colorants. Organic pigments are a type of colorant that are widely used in the production of plastics, textiles, and other products. Organic pigments are compounds that contain carbon and are synthesized through chemical reactions. Organic pigments have several advantages over inorganic pigments. They have excellent color strength and are often used to achieve bright and vivid colors. They are also more resistant to heat and chemicals, making them ideal for use in products that are exposed to harsh environments. Organic pigments can be easily dispersed in a range of media, including water, oil, and solvents, making them versatile and easy to use. Organic pigments are classified based on their chemical structure and the type of chromophore present. Chromophores are groups of atoms that absorb light and determine the color of the pigment. For example, azo pigments contain a nitrogen-nitrogen double bond and are used to create red, orange, and yellow shades. While phthalocyanine pigments contain a copper atom and are used to create blue and green shades. The synthesis of organic pigments is a complex process that involves multiple chemical reactions and steps. The process typically begins with the synthesis of the chromophore, followed by the coupling of the chromophore with other molecules to create the pigment. The process typically begins with the synthesis of the chromophore, followed by the coupling of the chromophore with other molecules to create the pigment. The resulting pigment is then purified and tested for color strength, tinting strength, and other properties. Organic pigments are used in a wide range of applications, including automotive coatings, printing inks, plastics, and textiles. They are also used in the production of consumer products, such as cosmetics, toys, and stationery. Chemistry plays a crucial role in the production of laundry detergent and cleaning agents. These products are used in households, commercial settings, and industries to remove dirt, stains, and other contaminants from surfaces and fabrics. In this article, we will explore the various applications of chemistry in the production of laundry detergent and cleaning agents. Surfactants. Surfactants are one of the most important components of laundry detergent and cleaning agents. Surfactants are compounds that reduce the surface tension of a liquid, allowing it to spread more easily and penetrate surfaces. Surfactants can be organic or inorganic, and their properties can be modified to achieve specific effects. In laundry detergent, surfactants are used to remove dirt and stains from fabrics. They help to loosen and lift dirt from the fabric, allowing it to be rinsed away in the washing machine. In cleaning agents, surfactants are used to remove dirt and stains from surfaces such as countertops, floors, and walls. Enzymes. Enzymes are biological catalysts that can break down complex molecules into simpler ones. Enzymes are used in laundry detergent and cleaning agents to break down and remove stains that are difficult to remove with surfactants alone. For example, protease enzymes are used to break down protein-based stains such as blood and grass stains, while amylase enzymes are used to break down starch-based stains such as food and mud. Bleach. Bleach is a chemical that is used to remove stains and whiten fabrics. There are two main types of bleach used in laundry detergent and cleaning agents: chlorine bleach and oxygen bleach. Chlorine bleach is a strong oxidizing agent that can remove tough stains and whiten fabrics. However, it can also damage fabrics if used improperly and can be harmful to the environment. Oxygen bleach is a gentler alternative to chlorine bleach that uses hydrogen peroxide or sodium percarbonate to remove stains and whiten fabrics. Oxygen bleach is less harmful to the environment and is safer to use than chlorine bleach. Builders. Builders are chemicals that are used to improve the performance of laundry detergent and cleaning agents. Builders can help to soften water, increase the pH of the solution, and improve the effectiveness of surfactants. Sodium tripolyphosphate, STPP, is a common builder used in laundry detergent. STPP can soften water and help to prevent the formation of mineral deposits on fabrics. In cleaning agents, builders can help to remove hard water stains and improve the cleaning power of the solution. Citric acid and acetic acid are examples of builders used in cleaning agents. Fragrances. Fragrances are added to laundry detergent and cleaning agents to improve their scent and enhance the overall user experience. Fragrances can be natural or synthetic and can be modified to achieve specific scents and effects. The use of fragrances in laundry detergent and cleaning agents can improve the perception of the product and make it more appealing to consumers. However, some people may have allergies or sensitivities to certain fragrances, and it is important to ensure that the use of fragrances is safe and does not cause harm. Bleach is a powerful chemical that is commonly used in laundry detergent and cleaning agents to remove stains and disinfect surfaces. There are two main types of bleach: chlorine bleach and oxygen bleach. Chlorine bleach is a strong oxidizing agent that is effective at removing tough stains and whitening fabrics. It is made by combining chlorine gas with a solution of sodium hydroxide, lye, or sodium carbonate, washing soda. Chlorine bleach is very effective at killing bacteria and viruses, making it a popular disinfectant for surfaces such as kitchen counters and bathroom fixtures. However, it can also be harmful if ingested or if it comes into contact with the skin or eyes. It can also damage certain fabrics and surfaces if used improperly. Oxygen bleach, also known as color-safe bleach, is a milder alternative to chlorine bleach that uses hydrogen peroxide or sodium percarbonate to remove stains and whiten fabrics. It is less harsh than chlorine bleach and is safer to use on colored fabrics. Oxygen bleach is also less harmful to the environment, as it breaks down into water and oxygen when it reacts with organic compounds. Both types of bleach have their advantages and disadvantages, and the choice of which to use depends on the specific application and the materials being cleaned or laundered. In addition to its use in laundry detergent and cleaning agents, bleach is also used in a variety of industrial and commercial applications, such as water treatment, pulp and paper manufacturing, and chemical synthesis. It is important to handle bleach with care, as it can be harmful to human health and the environment. When using bleach, it is important to follow the manufacturer's instructions and wear appropriate protective equipment, such as gloves and goggles. When using bleach, it is important to follow the manufacturer's instructions and wear appropriate protective equipment, such as gloves and goggles. It is also important to store bleach in a cool, dry place away from other chemicals and to dispose of it properly in accordance with local regulations. Fragrances are one of the key components added to laundry detergent and cleaning agents. They are added to these products to enhance their scent and create a more pleasant user experience. Fragrances can be natural or synthetic, and they are often blended together to create unique scents and effects. The use of fragrances in laundry detergent and cleaning agents can improve the perception of the product and make it more appealing to consumers. It can also create a positive association between the scent of the product and its cleaning power. In addition, fragrances can help to mask unpleasant odors from the materials being cleaned or laundered. There are many different types of fragrances used in laundry detergent and cleaning agents, ranging from floral and fruity scents to more subtle and earthy fragrances. Some fragrances are designed to provide a calming effect, while others are meant to be invigorating and energizing. The choice of fragrance used in a particular product depends on the intended use and the target audience. In recent years, there has been an increasing interest in the use of chemistry to create innovative and sustainable materials. With advancements in material science and technology, scientists and engineers are exploring new methods to create materials with unique properties and functionalities. In this article, we will discuss some of the methods used to create creative materials from chemical compounds. Polymer chemistry. Polymer chemistry is the study of polymers, which are long chains of molecules that are made up of repeating units. Polymers are used in a wide range of applications, from plastics and coatings to adhesives and textiles. The properties of polymers can be tailored by adjusting the molecular structure of the polymer, such as the length of the polymer chain and the type of monomer used. Polymer chemistry can be used to create materials with specific properties, such as high strength, flexibility, and resistance to heat and chemicals. Examples of materials that can be created using polymer chemistry include polyethylene, polypropylene, and polycarbonate. Additive technology. Additive technology, also known as 3D printing, is a method of creating objects by adding layers of material on top of each other. Additive technology has revolutionized the manufacturing industry, allowing for the creation of complex geometries and custom designs. Additive technology can be used to create materials with unique properties, such as high strength and flexibility. By adjusting the composition and structure of the material, scientists can create materials that are tailored to specific applications. For example, 3D printing has been used to create prosthetic limbs and dental implants that are customized to fit individual patients. Surface chemistry. Surface chemistry is the study of chemical reactions that occur at the surface of materials. Surface chemistry can be used to modify the properties of materials, such as their adhesion, wettability, and optical properties. One application of surface chemistry is the creation of self-cleaning materials, such as coatings and textiles that repel water and dirt. By modifying the surface of the material, scientists can create a hydrophobic, water-repelling, surface that prevents water and other liquids from adhering to the surface. This can lead to improved durability and cleanliness of the material. Nanotechnology. Nanotechnology is the study of materials at the nanoscale, which is approximately 1/1,000,000th of a meter. Nanotechnology has the potential to revolutionize the materials industry by creating materials with unique properties and functionalities. Nanotechnology can be used to create materials with high strength, conductivity, and optical properties. For example, carbon nanotubes can be used to create materials with high strength and conductivity, while quantum dots can be used to create materials with unique optical properties. Green chemistry. Green chemistry is the study of chemical processes and products that are environmentally sustainable. Green chemistry focuses on minimizing the use of hazardous chemicals and reducing waste and pollution. Green chemistry can be used to create materials that are sustainable and environmentally friendly. For example, bio-based materials, such as bioplastics and biofibers, are made from renewable resources and are biodegradable. These materials can be used as alternatives to traditional petroleum-based plastics and fibers. In conclusion, the use of chemistry to create innovative and sustainable materials has the potential to revolutionize the materials industry. By leveraging advances in material science and technology, scientists and engineers can create materials with unique properties and functionalities that are tailored to specific applications. As we continue to explore new methods and materials, the possibilities for creating creative materials from chemical compounds are virtually endless. Additive technology, also known as 3D printing, is a method of creating objects by adding layers of material on top of each other. The process of additive technology involves the use of computer-aided design, CAD, software to create a 3D model of the object to be printed. The 3D model is then sent to the 3D printer, which creates the object by adding layers of material one at a time. Additive technology has revolutionized the manufacturing industry, allowing for the creation of complex geometries and custom designs that would be difficult or impossible to produce using traditional manufacturing methods. The process of additive technology is also more sustainable than traditional manufacturing methods, as it generates less waste and uses fewer raw materials. One of the advantages of additive technology is its ability to create materials with unique properties and functionalities. By adjusting the composition and structure of the material, scientists can create materials that are tailored to specific applications. For example, 3D printing has been used to create objects with high strength, flexibility, and resistance to heat and chemicals. Another advantage of additive technology is its ability to create objects with complex geometries and internal structures. This is especially useful in applications where weight reduction and material efficiency are important factors, such as in the aerospace and automotive industries. Additive technology is also being used to create medical implants and prosthetics that are customized to fit individual patients. By using 3D printing to create these devices, doctors can ensure a precise fit and improve patient outcomes. However, there are also some limitations to the use of additive technology. One limitation is the size of the objects that can be printed, as the build volume of 3D printers is currently limited. Another limitation is the time it takes to print objects, as the process can be slow for large or complex objects. Surface chemistry is the study of chemical reactions that occur at the surface of materials. The surface of a material can have different chemical properties than the bulk of the material, and surface chemistry is concerned with understanding and modifying these properties. One application of surface chemistry is the creation of self-cleaning materials, such as coatings and textiles that repel water and dirt. By modifying the surface of the material, scientists can create a hydrophobic, water-repelling, surface that prevents water and other liquids from adhering to the surface. This can lead to improved durability and cleanliness of the material. Surface chemistry is also used in the development of corrosion-resistant coatings and materials. Corrosion occurs when a material reacts with its environment and breaks down over time, leading to structural damage and reduced performance. By modifying the surface of a material, scientists can create a barrier that protects the material from its environment and reduces the likelihood of corrosion. Another application of surface chemistry is in the development of materials with specific adhesion properties. Ultraviolet, UV, radiation is a type of electromagnetic radiation that is emitted by the sun and other sources. While UV radiation is necessary for life, excessive exposure can be harmful to human health, leading to skin damage, premature aging, and an increased risk of skin cancer. To protect against UV radiation, many products contain UV absorbers, which are chemicals that absorb UV radiation and convert it into heat. One of the key applications of chemistry in the production of UV absorbers is in the development of sunscreens. Sunscreens are designed to protect the skin from UV radiation by absorbing or reflecting it. The active ingredients in sunscreens are typically organic molecules that have the ability to absorb UV radiation. These molecules are carefully selected and formulated to provide broad-spectrum protection against both UVA and UVB radiation. Another application of UV absorbers is in the production of plastics and other materials that are exposed to UV radiation. Exposure to UV radiation can cause plastics to degrade, leading to discoloration, brittleness, and a reduction in mechanical properties. To prevent this degradation, UV absorbers can be added to plastics during the manufacturing process. The UV absorbers absorb the UV radiation and convert it into heat, preventing it from damaging the plastic. In addition, UV absorbers are used in the production of paints and coatings. UV radiation can cause paints and coatings to fade and degrade over time, reducing their aesthetic appeal and protective properties. To prevent this, UV absorbers can be added to paints and coatings to absorb the UV radiation and protect the surface from damage. UV absorbers are also used in the production of textiles and clothing. Exposure to UV radiation can cause fabrics to fade and degrade over time, leading to reduced durability and performance. To protect against this, UV absorbers can be added to fabrics and clothing during the manufacturing process. The UV absorbers absorb the UV radiation and protect the fabric from damage, improving its durability and longevity. In conclusion, the applications of chemistry in the production of UV absorbers are wide-ranging and important. From sunscreens and plastics to paints and textiles, UV absorbers play a critical role in protecting against the harmful effects of UV radiation. As we continue to develop new materials and technologies, the importance of UV absorbers in ensuring durability, performance, and safety will only continue to grow. One of the key applications of chemistry in the production of UV absorbers is in the development of sunscreens. Sunscreens are a type of topical product that is applied to the skin to protect against the harmful effects of UV radiation. The active ingredients in sunscreens are typically organic molecules that have the ability to absorb UV radiation. These molecules are carefully selected and formulated to provide broad-spectrum protection against both UVA and UVB radiation. One class of UV absorbers commonly used in sunscreens is benzophenone derivatives. These compounds absorb UV radiation by forming a complex with the radiation, which is then converted into heat. Benzophenone derivatives are effective at absorbing both UVA and UVB radiation and are commonly used in sunscreens and other topical products. Another class of UV absorbers used in sunscreens is the cinemates. These compounds absorb UVB radiation and are often used in combination with benzophenone derivatives to provide broad-spectrum protection against both UVA and UVB radiation. In addition to benzophenone derivatives and cinemates, other classes of UV absorbers that are commonly used in sunscreens include salicylates, avobenzone, and octocrylene. Each of these compounds has unique properties and absorption spectra, making them useful for specific applications. To ensure that sunscreens provide effective protection against UV radiation, the formulation of the sunscreen must be carefully balanced. The concentration and combination of UV absorbers must be optimized to provide broad-spectrum protection while maintaining product stability and safety. In addition to sunscreens, UV absorbers are also used in other personal care products, such as lip balms, hair care products, and lotions. These products contain UV absorbers to protect against the harmful effects of UV radiation on the skin, lips, and hair. Another key application of UV absorbers is in the production of plastics. Exposure to UV radiation can cause plastics to degrade, leading to discoloration, brittleness, and a reduction in mechanical properties. To prevent this degradation, UV absorbers can be added to plastics during the manufacturing process. The UV absorbers absorb the UV radiation and convert it into heat, preventing it from damaging the plastic. UV absorbers are commonly used in the production of polyolefins, which are a type of thermoplastic polymer. Polyolefins are widely used in a variety of applications, including packaging, automotive parts, and construction materials. However, exposure to UV radiation can cause polyolefins to degrade, reducing their mechanical properties and lifespan. To prevent this, UV absorbers can be added to the polyolefin during the manufacturing process. The UV absorbers absorb the UV radiation, protect the polyolefin from degradation, improving its durability and longevity. In addition to polyolefins, UV absorbers are also used in the production of other types of plastics, such as polycarbonates and polyesters. These plastics are used in a variety of applications, including electronic components, medical devices, and consumer products. UV absorbers can be added to these plastics during the manufacturing process to prevent degradation caused by UV radiation, improving their performance and longevity. The use of UV absorbers in plastics is particularly important in outdoor applications, where exposure to UV radiation is high. For example, outdoor furniture, playground equipment, and automotive components are all subject to prolonged exposure to UV radiation. By adding UV absorbers to the plastics used in these applications, manufacturers can ensure that the products maintain their appearance and performance over time. Another important application of UV absorbers is in the production of paints and coatings. Exposure to UV radiation can cause paints and coatings to fade and degrade over time, reducing their aesthetic appeal and protective properties. To prevent this, UV absorbers can be added to paints and coatings to absorb the UV radiation and protect the surface from damage. UV absorbers are commonly used in clear coatings that are applied to wood, metal, and other surfaces. Clear coatings are designed to enhance the appearance of the surface while providing protection against moisture, chemicals, and UV radiation. UV absorbers can be added to clear coatings to prevent degradation caused by UV radiation, improving the longevity and durability of the coating. UV absorbers are also used in colored paints to prevent fading caused by UV radiation. Colored paints contain pigments that give the paint its color. However, exposure to UV radiation can cause the pigments to fade, leading to a loss of color and a reduction in the aesthetic appeal of the surface. Chemistry plays an important role in the development and production of materials that are able to resist heat and flames. In this article, we will explore the various applications of chemistry in the production of thermal insulation and flame retardant materials. Thermal insulation materials are designed to reduce the amount of heat that is transferred through a surface. These materials are used in a variety of applications, including building insulation, refrigeration, and transportation. There are many different types of thermal insulation materials, each with unique properties and applications. One of the most common types of thermal insulation materials is fiberglass. Fiberglass is made from a combination of silica sand and other minerals that are melted together at high temperatures. The resulting material is then spun into fine fibers that can be woven into a mat or blanket. Fiberglass is an effective thermal insulation material because it is able to trap pockets of air, which act as a barrier to heat transfer. Another common type of thermal insulation material is foam insulation. Foam insulation is made from a variety of materials, including polyurethane and polystyrene. These materials are blown into a space using a special machine, where they expand to fill the space and create an insulating barrier. Foam insulation is particularly effective because it is able to fill even small gaps and spaces, providing an effective barrier against heat transfer. Chemistry is also used in the production of flame retardant materials. Flame retardant materials are designed to slow down or prevent the spread of fire. These materials are used in a variety of applications, including building materials, electronics, and textiles. One of the most common types of flame retardant materials is brominated flame retardants. These compounds contain bromine atoms, which are able to disrupt the chemical reactions that occur during combustion. Brominated flame retardants are commonly used in plastics, textiles, and electronics. Another common type of flame retardant material is intumescent coatings. Intumescent coatings are applied to a surface and react when exposed to heat, swelling and forming a thick layer that protects the surface from flames. These coatings are commonly used in building materials, such as steel beams and walls. Chemistry is also used to develop new flame retardant materials that are more effective and environmentally friendly. For example, researchers are exploring the use of nanotechnology to create flame retardant coatings that are more effective and require less material. In addition, researchers are exploring the use of natural materials, such as cellulose and chitin, as flame retardants. In conclusion, the applications of chemistry in the production of thermal insulation and flame retardant materials are extensive and important. These materials are used in a wide range of applications, from building materials to electronics, and play a critical role in protecting against heat and fire. As our understanding of the properties and behavior of these materials continues to grow, we can expect to see continued innovation and advancement in the field of thermal insulation and flame retardant materials. Thermal insulation materials are designed to reduce heat transfer through a surface by trapping air or another insulating material within the material. These materials can be divided into two categories: reflective insulation and bulk insulation. Reflective insulation consists of a highly reflective material, such as aluminum foil, that is applied to a surface. This reflective surface reflects radiant heat away from the surface, reducing heat transfer. Reflective insulation is commonly used in roofing and wall systems, and is particularly effective in hot climates. Bulk insulation, on the other hand, consists of materials that are able to trap air or another insulating material within the material itself. This trapped material acts as a barrier to heat transfer. Some common bulk insulation materials include fiberglass, mineral wool, and cellulose. Fiberglass insulation is made from molten glass that is spun into fine fibers. These fibers are then pressed into bats or rolls and installed in the walls, floors, or ceilings of a building. Fiberglass insulation is effective because the trapped air within the material is a poor conductor of heat. Mineral wool insulation is made from a combination of rock and slag wool. The materials are melted at high temperatures and spun into fibers. The fibers are then compressed into bats or rolls and installed in a building. Mineral wool insulation is effective at reducing heat transfer because the fibers trap air within the material. Cellulose insulation is made from recycled paper products, such as newspapers and cardboard. The paper is shredded and treated with chemicals to make it fire-resistant. The treated paper is then blown into walls, floors, or ceilings using a special machine. Cellulose insulation is effective at reducing heat transfer because the paper fibers trap air within the material. In addition to reflective and bulk insulation, there are also other types of thermal insulation materials, such as foam insulation. Foam insulation is made from materials such as polyurethane and polystyrene, which are blown into a space and then expand to fill the space. Foam insulation is particularly effective because it can fill even small gaps and spaces, providing an effective barrier against heat transfer. Fiberglass is one of the most commonly used types of thermal insulation materials. It is made from a combination of silica sand and other minerals that are melted together at high temperatures. The resulting material is then spun into fine fibers that can be woven into a mat or blanket. Fiberglass insulation is available in a variety of forms, including bats, rolls, and loose fill. Bats and rolls are designed for use in walls, floors, and ceilings, and are typically pre-cut to fit between standard stud and joist spacing. Loose-fill fiberglass insulation is designed for use in attics and other areas where it is difficult to install bats or rolls. Fiberglass insulation is effective at reducing heat transfer because the trapped air within the material is a poor conductor of heat. This makes it an effective barrier against both heat loss and heat gain. Fiberglass insulation is also lightweight and easy to install, making it a popular choice among builders and homeowners.